Hello, I'm Robert Beland from Yokogawa Corporation of America. This series of 6 videos will cover the math operations of the Smart DAQ series recorders. What to expect from this video in class. The main part of the discussion will be based on the Smart DAQ GX 10 and 20 math functions. Step-by-step examples of how to set up a T-log statement, rolling average, hold, and using an if-then-else statement will be featured. The main goal of this class is to become familiar with the /MT or the math feature of the GX and GP. It is expected that anyone attending this has already programmed or at least understand how to enter the settings section of a GX GP recorder. Upon completion of this presentation, all attendees should be able to configure the most common math questions that arise. How do I set up a totalizer using a tlog.sum? You'll see that in an example. How to set up a rolling average and how it is different from a standard T-log average. How to build a simple counter using an if-then-else statement, and how and when to use the hold expression. First, what can I put in a math statement? Math statements can contain input channels, computed data from other math channels, constants, communication data, flags, and/or switches. Each math channel is limited to 120 characters of math. The maximum number that can be displayed in this math is 99,999,999 with no decimal places selected. So make sure you make a note of that. If you have 2 decimal places, then that drops that number down to 999,999.99. If you exceed this number, you will get a plus over in the display and your math will have to be stopped and manually resetted. As a result of that, we'll show you some different examples of ways to take large numbers and divide them later on in the presentation. The result in computation can be displayed and stored in the GXGP data file. And one important thing to note is that the computation is based on the scan interval. So if you're scanning once a second, that's what your computation will be based on. If you're scanning once every 2 seconds, 5 seconds, or in the case of the GX or G20, you can scan every 100 milliseconds or 10 times per second. Math channels. Math channels for the GXGPs are and start at A001 and above. Here's just a quick example. For the smaller 6-inch GX GP10, you have 50 math channels. And then for the larger case 12-inch display GX GP20, there are 100 math channels available. Overview of math functions. Won't bore you too much with details here, but basically you must remember that anything that you put in a math statement, if you put a number in a math statement, it's going to be treated as a channel number, not a constant. So if you put 2 in there, it's going to appear to be channel number 2, not the number 2. As a result, we have constants that are available, K01 through K100, so 100 of them, that you can program for different numbers. Example would be K01 equals 1, K02 equals 45.38, etc. As for operations, the standard plus, minus, multiplication, and division are standard functions. Then there's a square root extraction formula used by the SQ. There's also an absolute value, ABS, that will return a non-negative number of whatever you put in the parentheses. There's also a log that determines the common log, basically y equals log 10x. And there's an exponential that will basically give you the y equals ex formula. Then also there's relational computations, which are less than equal, greater than equal, equal or not equal to. And those return outputs of either true or false. In this case, seeing this as numbers, you'll get a 0 or 1, 0 being false, 1 being true. Then there's also the standard logical computation, and ors, exclusive ors, or nots that of course return the same 0 or 1, true or false in this statement. Then we get to some of the more highlighted and some of the examples we'll be covering. The statistical computation. These are the T-log, and these are sums, max, mins, and peak-to-peaks. And there's also timers that can be set for the different intervals for that. We'll cover that later on in the associated videos. There's also group statistics. These are C-logs that also come along with sums, mins, max, averages, and peaks-to-peaks. And the nice thing about this is you can do 30 channels in each statement. Example would be as if you were looking for the maximum out of a group of 30 channels, you could do a clog.max and put channels 1 through 30 in the parentheses. It would return the number. It wouldn't tell you which one was the greatest, but it would tell you the number or the value of the max number, the max channel in that group. Then previous is a statement that's used for looking at the previous scan interval of a channel. So in other words, when you're trying to see what the value was before it just got updated, you can do a previous and that will return that. There's also a hold, a reset, and a carry function. Those are used to basically, it's kind of like an if-then statement where if something on the left side of the statement is true, then the right side or the other side of the colon will be true, and then if it's false, it'll be the opposite. The carry statement can only be used with the tlog.sum, and that's for an instance of when you're summing something and maybe you want to get to a total of 5,000 and then roll over and start counting again. If you got to 5,001, typically that number would be chopped off and you would only see the 5,000. The carry function lets that additional 1 scroll over or roll over into the next total. Then the if then else statements, and we'll explain that a little bit later on in the presentation. We'll skip by this. There's not too much information in here. I understand most people probably understand how to add and subtract numbers, but just remember if you do like a 001 plus 002, you're adding the two channels, number 1 and number 2 together. You're not adding, your result is not going to be 3, okay? Same thing with subtraction. If you want to multiply a channel or add it, you need to use one of those constants we talked about earlier. So 001 times K01 would multiply the value of channel number 1 times whatever value you put in the constant. Same thing for a divide. Then there's also the power, square root, absolute, log, and exponential computations. Same kind of thing. You can look on here and see, channel number 1 is 001, asterisk, asterisk, 002. That's going to basically, that's not going to take channel number 1 and square it. It's going to take channel number 1 and square it by the value of channel number 2. Then there's a square root, absolute, log, and exponential. We kind of discussed those earlier. There's just an example of what that formula would look like. The relationship computations, you'll see these are, 001.lt.002. That's just channel number 1 less than channel number 2, and if that's true, you'll return a 1. If it's not, you'll get a 0, and those can be used in conjunction with some of the and features or features or if then else statements later on, where you can test or see if something is true to give you one result or the other. As you can see, you can do greater than, equal, not equal, greater than or equal to, or less than or equal to. You can also use the actual the symbols too instead of the .ge dot. Then your and ors, exclusive ors or nots. 001 and channel number 2. If both of those are true, you'll get a 1. If not, you'll get a result of a 0. Just remember that's an and statement, but that's the same kind of thing as multiplying those two channels together. But the difference was if you multiply channel 1 and 2, you'll actually multiply their values together. So if they were both 50 degrees C, you would in chance be multiplying 50 times 50, whereas if you take channel number 1 and it to channel number 2, you're just testing to see if they're both non-zeros, and your answer would be a 1, not basically 2500. Then the T-log statement, which we'll cover in detail in just a little bit in a separate video along with this set of videos. But T-log.max, T-log.min, average, sum, and peak to peak, and you can see that they'll return the maximum of that channel, the minimum of that channel, and that's based over time, and we'll discuss that when we show you how to assign that to a timer. C-log is basically the same thing. The difference is that it's a group of channels. If you do a C-log max and you do 001.002.003, you'll basically return the maximum value of channels 1, 2, and 3 combined together. If you do more like the C-log min statement here, 001 minus 010, then you'll be selecting the minimum from channels 1 through 10. So you can either use a dash if the channels are connected, or dot if you need to separate them or expand out. And again, you can do channels 1 through 30 max. So you can do 30 of them max in each one of the C-log statements. Special features, I'll just touch on just a little bit. We're not going to have a separate video on each one of these, but there's a bit feature. These came along with the release 2 of the GX firmware. This just returns some lower level status from the Modbus. If you're looking to see a bit from a third-party device, which is an alarm or something, is true, you can do a bit operation and bring in that value. The integer is a nice feature that's been used a couple of times. It just returns the whole number or the integer of the number, so 123.45 just returns a result of 123. Then there's also a mod, which basically extracts the remainder. Again, these are used rarely. They do have some benefit, but not a whole lot of time are these readily used. Then, of course, the standard sine and cosine, just returning the angles or the cosine of the angle. Just a quick presentation or shown of what, when you choose the recorder, what your screen will actually look like when you choose one of the math equations. As you can see, all the T-logs and sums and everything like that. And now what we're going to do is move on to an actual example in the next video.